Hello, my name is Lisa Greco, and I'm from Palm Bay High School in Brevard County, and welcome to my Mathematical Connections presentation. Mathematical connections help students in many ways. They're able to learn that mathematical concepts and practices are interrelated. They get to understand how to apply these mathematical concepts to real-world situations. They can discover new learning and reflect on the results, as well as understand why mathematical concepts work and how to use them in different contexts. The current courses I am teaching this year are Algebra 2 and Math for College Algebra, or known as MCA. They're both advanced algebra courses. These math classes do have their foundation starting back in elementary school, where numerical expressions and one variable one-step equations were introduced. As a student progresses through middle school, you can see per the chart, students become involved in multi-step equations as well as two-step inequalities. They are graphing lines and their properties are introduced. As they move per the chart in Algebra 1, you have the abstract variable expressions becoming the focus. Students learn new functions such as quadratic, absolute value, and exponential. They expand their graphing knowledge by creating two variable equations in different forms. Algebra 1 is also where they start to make connections between graphing and algebraic methods while solving linear systems of equations. As students enter in Algebra 2, they expand their polynomial work into the complex number system, where they solve all quadratic equations using multiple methods. In this course, students explore more advanced functions such as radicals, rationals, logarithmic, and exponential, using both algebraic methods and graphing. They also expand on inequalities by solving and graphing absolute value and quadratic inequalities. Finally, the nonlinear systems are explored both graphically and algebraically. During Algebra 2, we begin with linear functions and introduce symmetry with absolute value. This leads to exploring quadratics, which becomes the foundational function used to introduce higher degree polynomials. Per my chart, you can see how the quadratic leans into the higher order degree polynomials, the rationals, and the logs, and then the exponential. The course also highlights the connections between all the graphing features such as extrema, intervals, and behavior. Algebra 2 has many opportunities to connect beyond the course. Many functions such as linear or quadratics are rooted in real-world connections. We connect to science and social studies as we analyze real-world situations through data analysis. Algebra 2, other real-world contexts can be found in solving applications of linear systems, and I have attached some student work of an application assignment we did this fall. The concept of graphing a system has long-term connections. First, the students need to graph a line using slope and y-intercept. Second, they need to be able to graph these points on a coordinate plane and connect them into a line. And after graphing the second line, they learn that intersection point is the solution of the system. Solving a systems application problem is a great example of using multiple representations. The problem is listed in the upper right-hand corner, and the first column marked verbally walks through the process of students identifying key information, defining the variables, and writing the equations needed to solve the system. My second column details how to solve the system with the visual of the graph and graphing calculator technology. The third column is the steps for substitution, which detail the steps symbolically. In conclusion, mathematical connections are important because students can see the relationships between different mathematical concepts. They deepen the students' understanding and promote problem-solving abilities and enable them to apply math knowledge across various contexts. They make mathematics more meaningful and relevant to real-life situations. Thank you.